Bismillah, the 125 kilogram concrete block A is released from the rest. So initial velocity will be 0 for this. In the position shown, and pulls the 200 kilogram log up with a 30-degree ramp. The kinetic friction coefficient is given, it is 0.5. We have to find the velocity of block as it hits the ground B. So what will be the velocity at B position? So we can say initial velocity is 0 and we have to find the velocity at 0.2. Now guys, let's see this problem. We can see that the mass is given in this problem. So what type of concept can be applied? So kinetic friction is also given and the motion is a constraint. I mean the two bodies are connected each other. So we can apply two concepts here very easily. The equation of the motion first, and secondly the constraint motion rules or concepts. To solve this problem, we will first try to correlate or make some relationship between this log and the block A. It means that how velocity or acceleration of two bodies are related. I will write L is equal to the displacement happening for the body C. Suppose I will say this is a body C. So I can write the 2 times displacement made by these two cables plus 1 time displacement made by the cable of the body A. So from this equation we can easily write the acceleration formula, and this will be equal to double time of differentiation. So we can write 2 times acceleration of the body C plus the acceleration of the body A is equal to 0. Now we will move to solve the equation of the motion. Okay, to solve the equation of motion we need to make free body diagram. And in this problem we can see that we have two bodies, the body A which has 125 kilogram mass, and the another log, the body C, we can say having mass of 200 kilogram. So let's make free body diagram. In this picture you can see that the body C is on a surface, okay, and it is pulled by 2 cables. So I can write there are 2 tension cables. Secondly, it has a mass, so we can say okay, mg weight is working downward direction, and the normal force perpendicular or normal to the contact surface. And since there is a friction factor, so we know that there is a friction force which is working opposite to the direction of the motion. So we can say okay, this is Fk, and as you know that Fk is equal to mu k multiplied by n, normal force. We need to find this normal force in order to find the Fk. So this is all about the body C. Now let's move to the body A. Here we can see that there are 2 cables, one cable, and which is working in upward direction. So I can say T, the mg is working downward, okay. There is no normal force because there is no contact surface here. Now we have to choose a proper coordinate for it. So because the motion is linear, we can use x and y coordinate. In this problem, we can choose x positive in this direction. You can choose another direction also, it's not a problem. Okay. So now I will write, or I will solve the equation of motion for the body C. F is equal to ma, and this I can make a component. Fx is equal to max, or acceleration of the body C. Now let's solve this equation. Let's see what are the forces working in x direction for the body C. So it is very clear from the picture, free body diagram, Fa is working in positive direction. So I will write Fk, that is mu k multiplied by n minus 2t in another direction, and the component of mg in plus direction, mg sine 30 is equal to mass of this body and AC. Guys, let's find what are the unknown in this problem or in this equation. So since n is unknown now, t is unknown, and AC is unknown, so we can very easily find n from the equation of Fy. The rest is t and AC, and as you know that the acceleration formula we already made, to 0 is equal to 2AC plus AA. So we can also use, we will use this formula, or we will use this relationship. So this is our equation 1. Now let's go for Fy is equal to MAY. Since there is no motion in y direction, guys, you see here, so I can say Ay is 0, or simply MAY is equal to 0. So in this case I will bring all the forces in y direction. So here I can see that normal force is working plus normal force minus mg and its component cos 30 is equal to 0. So we can simply find n, because we already know m of this body. So it is 1699 Newton. Now we will solve for the body A, and since the motion in only one direction, in vertical direction, so I can write F is equal to ma and the acceleration of the body A, to be very specific. Let's write the mg, which is working downward direction, so I can write mg minus t is equal to may. Now put the values here, 125 kilogram multiplied by 9.81 t a. In this equation there are two unknowns, this and this. Okay, so we can utilize the formula we already made from the constant motion is equal to minus a. Okay, we can utilize this here to replace the acceleration due to the c's. Here you can see we already mentioned this previously. Now guys, based on this equation 2 and this equation 3, we can calculate the acceleration A of this body. It is 1.77 meter per second square. The acceleration of the C, 0.88 meter per second square, and tension T is equal to 1004 Newton. Now in this problem they asked what will be the velocity when it will drop to 6 meter down at this position. So velocity at point 1 is 0, and we have to point at point 2 velocity. So we can write the formula v square 2 is equal to v1 square plus 2a and the displacement. The initial velocity, it just starts from 0, so we can write it is 0, and we can find v2 is equal to the acceleration of the body, what? The acceleration of the body a, multiplied by the distance 6 meter. So from this formula we can easily find velocity at the point 2, that will be 4.62 meter per second.